Great morning, dear students. This is your mathematics class. In this class, today we are going to discuss chapter 4, Quadratic Equations. In this chapter, we will understand, recall and review quadratic polynomial to form a quadratic equation from a worded statement, standard form of the quadratic equation, and note the coefficients of x square, x, and constant term. We will find the solution of the quadratic equation by three methods. One is factorization method, second is by completing the square method, and third is by using quadratic formula. And also we will explore the nature of the roots. First topic is standard form of a quadratic equation. When we write the terms of px in descending order of their degrees, then we get the standard form of the equation. A quadratic equation. What is the quadratic equation? In which degree of the variable is 2. So degree means highest power of the variable. A quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0. This is the standard form of quadratic equation. Ax square plus bx plus c is equal to 0, where a, b, c are the real numbers, and this condition is very important. A is not equal to 0 because if a will be 0, then it become the linear. Okay, so we will always write a is not equal to 0. I've taken two example here. 2x square plus x minus 300 is equal to 0. You can see that the degree is in descending order, the power is in the descending order, so that means it is the standard form of the quadratic equation. In second example, you can see that this is not the standard form, because when we compare this it by ax square plus bx plus c is equal to 0, you can see that clearly it is not in the standard form. Next is roots of the quadratic equation. In previous classes already you know that how to find the zeros of the quadratic polynomial, or now we are going to discuss zeros of the quadratic equation, zeros and roots. When we are discussing about the polynomial, then we use word zero, and when we are going to discuss about the quadratic equation, then we will say the word roots. So these are the same thing, roots, zeros, and the solution. What are these? The value of variable x means the value of the variable which satisfies the equation, then that value is called the zeros or roots or solutions of the quadratic equation. So value of x at which px is equal to 0 is called the solution and roots of the quadratic equation. Next is real world example. Why I have taken here, because we should know why we are studying quadratic equation. When you will plot the graph of the quadratic equation, you will get the graph will be U shape. Always graph become in U shape. Okay, it is also called the parabola. So when you will see some in real life example, you can see clearly where we are using quadratic equation. Now we are going to discuss the first topic. In first topic only we are going to check is the given equations are quadratic or not. So I have taken exercise first exercise 4.1, first example. X plus 1 whole square is equal to 2 into x minus 3. So you know that the identity a plus b whole square. So a plus b whole square, we know that a plus a square plus b square plus 2ab. So we will use at the left side a square plus b square plus 2ab is equal to, when we will multiply 2 by x and by minus 3, you will get 2x minus 6. When you will solve this equation, you will get x square plus 7. So is it quadratic? Yes, it is quadratic, because degree of the quadratic equation is 2. So that means it is a quadratic. Now we will represent some situational question. We will do some situations are given. We will form quadratic equation. The first is the area of a rectangular plot is 528 meter square it is, and the length of the plot is one more than twice its breadth. So suppose that it is a rectangular plot. So first read the statement carefully. Always break the statement and then read it. The length of the plot in meters is 1 more than twice its breadth. So first we will assume the breadth. Let the breadth be x meter. So length is twice its breadth, 2x plus 1. 1 more than twice its breadth. So length become 2x plus 1. So according to the question, how will we find the area? Length into breadths. So x into 2x plus 1 is equal to 528. When you will solve that, you can make it quadratic. 2x square. Here square is there. Square is missing. So you can write down 2x square plus x minus 528 is equal to 0. So yes,